Hello and welcome to MakeLearn 360. In this video, I want to solve a problem with you to illustrate the concept of equilibrium of a particle. Alright, so let's read the problem together and solve it. Alright, so I have two forces. Alright, let's read it together. Two forces P and Q are applied as shown to an aircraft connection. Alright. Knowing that the connection is in equilibrium, so this is the connection, it is in equilibrium, and that P is 500 pounds, P is 500 pounds, Q is 650, so that is Q. Now our task is to determine the magnitude of the forces exerted on rods A and B. Simply put, we should find FA and then FB. All right. So what are the conditions for a particle to be in equilibrium? Sum of forces in all directions should be 0. So sum of forces in the x direction will be 0. Sum of forces in the y direction will also be 0 as well. All right. Now let's choose a convention then. So this is the convention we will choose. Every force in the x direction in this way is going to be positive, and then every force in the y direction in this way is going to be positive. So let's start by summing forces in the x direction. So summation of forces in the x direction, every force in this direction should be positive. Okay, so then let's start. Should be equal to 0. FB is already oriented to be in the x direction, and so it is here is going to be FB positive. Now looking at FA, FA is making an angle 50 degrees with the horizontal, and so the component of FA along the x is going to come this way, and then the component of FA along the y is going to come this way. So the x component is going to be cosine, which is minus FA cosine 50. And then this part is going to be, no, we are summing forces in the x direction. All right. P is vertically downwards. And since P is vertically downwards, it means that it does not have any component along the x. Now let's look at Q. So this is the line of action of the Q, and then Q is making an angle 40 with the vertical, and so the horizontal component of Q is going to be sine, so which is going to be, but it's going to be positive because it is in this direction, it is in the direction that we chose. So 650, that is Q. 650 sine 40. Is there any other force we have not looked at or considered yet? No. So the summation of forces will be 0 as shown. Let's try to rearrange this. Then I have, so cosine 50. Cosine 50 is going to be 0.643. So I'm going to do FB minus 0.643 FA should be equal to, so I'll send this guy here, 650 sine 40. So 650 sine 40 is 417.812. So minus 417.812. Let's call this equation 1. From here, let's try to sum forces in the y direction. Every force going up is positive, should be equal to 0. Now FB is along the x direction, it does not have any component along the y, so 0 for FB. Considering FA, this time around the y component of FA is in this direction, and so it's going to be positive. and it's also sine because this side is opposite to this side. The 50 is opposite to this side. So it's going to be FA, so plus FA sine 50 degrees. All right. Now, let's look at P. So P is coming vertically downwards, and that is 500. So it's going to be minus 500 because it is coming down. Interestingly, considering K, we can see that the vertical component or the y component of K is in the same direction as P. So the y component of K is going to be K, which is 650 cosine. All right, so this side is going to be cosine, and this side is sine. Take notice of that. So it means that I'm going to do minus because it's coming down 650 cosine 40 should be equal to 0. Is there any other force we have not considered yet? No. All right, so I can say that. All right, so let's solve for FA. Solving for FA, I can say that FA sine 50 is actually equal to 500 plus 650 cos 40. And what is that? But this equation is supposed to be our equation 2. So clearly I can say that 500 plus 650 was 40. All right. And that is this. So 997.92888. Okay, so let's say 997.93. 997.93. Therefore, FA is going to be 997.93 divided by sine 50. And what is that? So I'm going to get 997.93 divided by sine 50. All right, and that's 1302.705. 1302.705 pounds. So that is the force in rod A. Let's calculate the force in rod B. So we will say that put FA equals 1302.705 pounds into equation 1. All right, so let's put FA into equation 1. I'm going to get FB as, so let's do it. FB is going to be equal to minus 417.812 plus 0.643 FA, which is 1302.705. Therefore, FB is going to be minus 417.812 plus 0.643 into 1302.705, and that's going to be 419.827. 419.827 pounds. So that's FA and FB for you. All right. So the concept here is that whenever a particle is in equilibrium, so the whole of these forces were acting at this point. So we're assuming that everything here is acting on this particle, and that is the aircraft connection. So for equilibrium of such a particle, summation of force in the x direction is 0, summation of force in the y direction is 0, and then you solve for the unknowns. Thank you very much for watching.